Good morning, student, and welcome to lecture. Today's lecture on physical chemistry, and I will explain you in this lecture the details regarding photoelectric effect. Before that, I would like to explain you introduction of electromagnetic radiation. All of you know electromagnetic radiation. It is one form of energy and it has either wave nature or particle nature. Then it consists of quantas or photon. The electromagnetic field propagating or radiating through space carrying electromagnetic radiant energy. And electromagnetic radiation, it is composed by means of electric component and magnetic component, and they are at right angle to each other, and this is the propagation of electromagnetic radiation. Then here the electromagnetic spectrum, it consists of the gamma rays, X-rays, ultraviolet rays, infrared, radar, FM rays, TV rays, soft waves, and AM waves, and all these waves they have their particular wavelength, particular frequency, and arrangement of the waves either in increasing order and frequency in a decreasing order. This arrangement of particular rays in it is nothing but electromagnetic spectrum. And here there is a visible light, and the range of visible light it is in between 400 nanometer to 700 nanometer, and it consists of the particular color to particular wavelength, and this is just like a rainbow. This is a diffused spectrum. There is no clear-cut separation between where the red color starts and where the yellow color ends. That means this is a diffused spectrum. This is just like a rainbow, and this is a visible range. Then here, when a white light it passes through a Nichols prism, there is a diffraction of light takes place, and this diffraction we call as a spectrum. Here, this spectrum it consists of the seven colors. They are diffused into each other, having particular wavelength and particular frequency. As the wavelength is greater, the energy is less, and as the wavelength is shorter, energy is greater. This is the according to Planck's radiation law or theory. We know energy associated with one quantum, it is given by E, it is equal to h nu, where h it is the Planck's constant and the nu it is the frequency. Here the scientist J.J. Thomson observed that when light of certain frequency strikes the surface of metal, electrons are ejected from the metal, and this phenomenon is known as photoelectric effect. Now, today's our discussion point it is the photoelectric effect. The scientist J.J. Thomson observed that when light of certain frequency strikes the surface of metal, electrons are ejected from the metal, and this phenomenon is known as photoelectric effect. In other words, we can say that photoelectric effect it is nothing but ejection of electron from metal surface when that metal surface is exposed to either UV or visible light. Then the experimental setup for observation of photoelectric effect. This is a evacuated tube, and it is fitted with anode and cathode. and here the cathode, it acts as a metal plate. When the UV or visible light, it is incident on the metal plate, as soon as the incident light is strike on the metal surface, the electrons are ejected, and these electrons are called as photoelectrons. And this uh, cathode and anode, that means negative electrode and positive electrode, they are connected through battery, and the current passed, it is measured in this galvanometer. Here the current passed in this circuit, it is due to photoelectrons. This is the schematic representation or experimental setup for the study of photoelectric effect. Remember well that this is a evacuated tube. That means there is no any type of air in this tube, and here there is a metal plate, it acts as a cathode, and here it is a anode. Then as soon as the ultraviolet or visible rays they incident on the metal plate, the ejection of electrons takes place, and they get migrated towards the positive electrode, and thus we can measure the photoelectric current in the galvanometer. Then the electrons are ejected as soon as light strikes on the metal. That is, there is no time lag between strike of light and ejection of electron. Then the number of electrons emitted is proportional to the intensity or brightness of the light. For each metal, there is a characteristic minimum frequency, and that is characteristic or minimum frequency is called as threshold frequency. In your book, this threshold frequency, it is denoted by letter phi, below which the photoelectric effect is not observed. Then the photo at a frequency less than threshold frequency, the ejection of electron come out with certain kinetic energy, and the kinetic energy of these electrons increases with increase of frequency of the light used. Again, I will repeat, the photoelectric effect is the emission of electrons when electromagnetic radiation such as light hits a material, that means any metal. Electrons emitted in this manner are called photoelectrons. This phenomenon is studied in a condensed matter in physics and solid state and quantum chemistry. To draw inferences about the properties of atoms, molecules, and solids, the effect has found use in electronic devices, the specialized for light detection and precisely timed electron emission. Then the characteristics of photoelectric effect. These are: first characteristic, photoelectrons are emitted only when frequency of incident light exceeds a certain minimum frequency, and that frequency of light required to eject electron. This frequency is known as threshold frequency. The light with lower frequency than this cannot eject the electron even when high intensity of light is used. The value of phi is different for different metals. This is the first characteristic of photoelectric effect. The ejection of electron, it takes place only when the frequency of light it is greater than the threshold frequency, that is the minimum frequency required for the ejection of electron, and each metal it has a different threshold frequency. Then the second characteristic, the kinetic energy of ejected electrons varies directly with the frequency of incident light, but it is independent of intensity. Remember, the kinetic energy of ejected electron, it varies directly with the frequency of incident electron and it is independent on the intensity of light. Then the third characteristic, as the intensity of incident light increases, the number of ejected electrons also increases. Remember that as the intensity of incident light increases, the number of ejected electrons also increases. Then this results in increase of photoelectric current. Then the fourth characteristic, even at a low intensity, electrons are ejected immediately after the frequency of light is above threshold frequency. And according to classical theory, the energy of light depends on intensity. Hence, it fails to explain photoelectric effect. Then in 1905, a scientist, Albert Einstein, explained the photoelectric effect by applying Planck's hypothesis. That means when a photon of light of frequency nu zero strikes an electron in a metal, it imparts its entire energy to the electron. So electrons overcome the attractive influence of nucleus and get ejected. Thus, each photon can eject one electron. If the frequency of light is less than nu zero, there will be no ejection of electron takes place. Now, if the frequency of light falling on metal surface is higher than the threshold frequency, some of its energy is consumed to separate the electron from metal and remaining part appears as a kinetic energy. Then as per the law of conservation of energy, we can write the equation H nu it is equal to phi plus 1 half m v square, where 1 half mv square it is the kinetic energy of the electron and phi is the work function or threshold frequency of ejected electron. Again, we know that phi it is equal to h nu 0 and substituting these two equations we get here h nu it is equal to h nu 0 plus 1 half mv square. Therefore, 1 half mv square that means the kinetic energy of the ejected electron it is equal to h nu minus h nu 0 and we can write there is a h common in the two terms. Therefore, we can write 1 half mv square it is equal to h up in a bracket nu minus nu 0 and the significance of this equation is that if the light frequency is such that nu is less than nu 0, no electrons are emitted. The kinetic energy of ejected electrons directly varies with increase in frequency and if we plot the graph of kinetic energy versus the frequency of incident light, we get a straight line graph with the intercept on x-axis and here the value of h is obtained from the slope and it is the same as it is given in the Planck's hypothesis. That means by the graph of 1 half mv square that means kinetic energy of ejected electron versus frequency of incident light we get a straight line curve with intercept on x-axis and the value of intercept on x-axis it gives the threshold frequency. This is the photoelectric effect. Then again I will repeat once again the today's point, introduction to electromagnetic radiation. Remember that The electromagnetic radiation, it is one form of energy and it consists of either wave nature or particle nature, and it propagates through a space carrying electromagnetic radiant energy. Then electromagnetic radiation, it is composed by means of electric component and magnetic component oscillating at a right angle to each other in the direction of wave propagation. Then here the electromagnetic spectrum or electromagnetic radiation. Here the electromagnetic spectrum, it is the arrangement of different wavelengths in increasing order or decreasing frequencies, and this arrangement it is called as electromagnetic spectrum. And electromagnetic radiation, it consists of gamma rays, x-rays, ultraviolet rays, UV rays, that means visible light, infrared, radar rays, FM, TV, soft waves, and AM waves, etc. And the range of visible light, it is in between 400 nanometer to 700 nanometer. Then the diffraction of white light, when a white light passes through Nichols prism, here we have, this is the spectrum. That means one ray of white light, it gets separated into 7 colors, and this is a diffused spectrum. Each color, it has its specific wavelength, specific frequency. Then Sir J.J. Thomson observed that when light of certain frequency strikes the surface of metal, electrons are ejected from the metal, and this phenomenon is known as photoelectric effect. Then the schematic experimental setup for the study of photoelectric effect. This consists of evacuated tube in which there is a positive electrode, that means anode, and here metal plate, it acts as a cathode, that means negative electrode, and these two electrodes are connected through galvanometer and battery. As soon as the ultraviolet rays or visible light, it is incident on the metal plate, ejection of electrons takes place, and that electrons, they get migrated or they get flow towards the positive electrode. These electrons are called as photoelectrons, and the current is the photoelectric current. Then here the summary of the photoelectric effect. The electrons are ejected as soon as light strikes on the metal. There is no time lag between strike of metal and ejection of electron. The number of electrons emitted is proportional to the intensity, that means brightness of the light, and for each metal there is a characteristic minimum frequency called threshold frequency zero. It is essential for the ejection of electron, and below this frequency, threshold frequency, the ejection of electron does not take place. That means below this frequency, photoelectric effect is not observed. At a frequency nu is greater than nu zero, the ejected electrons come out with certain kinetic energy, and the kinetic energy of these electrons increase with increase of frequency of the light used. Then here again photoelectric effect is nothing but the emission of electrons when electromagnetic radiation such as light hits a metal. Electrons are emitted in this manner, and that electrons are called as photoelectrons. Then we will see the characteristics of the photoelectric effect. The first characteristic, photoelectrons are emitted only when the frequency of incident light exceeds a minimum frequency, that is threshold frequency. If the frequency is less than the threshold frequency, no ejection of electron takes place. This is the first characteristic. Then the second characteristic, kinetic energy of ejected electron varies directly with the frequency of the incident light, but it is independent on intensity. And as the intensity of incident light increases, the number of ejected electrons also increases. This results in the increase of photoelectric current. Even at low intensity, electrons are ejected immediately if frequency of light is above zero. And according to classical theory, the energy of light depends on intensity, hence it fails to explain photoelectric effect. So the scientist Einstein in 1905 explained the photoelectric effect by applying Planck's hypothesis. This is the today's lecture regarding photoelectric effect. Thank you for your listening.